to the first power? 4. Very good. So what would be 4 squared? 16. Those are easy things to come up with, right? You got that pretty quickly? So what if I said I wanted to find 4 to the 1/2? Maybe. Why did you pick 2? So half of 4 to the first power is 2. Let's see if that works consistently. So we're guessing what? 2. We're guessing what else? 8. Any other guesses? No other guesses?
1.
1. Why would it be 1?
Oh, no.
Well, I guess I shouldn't have done that. 4 to 1/2, I should put it up here, shouldn't I have? Not in the middle. That was probably confusing. Let's put it up there. 1/2 is smaller than 1, right? I shouldn't have put it in the middle. So 2, it would not be 8, because 8 would fall somewhere in here, right? Could be maybe 1, but we said anything to what power is 1? Anything to the 0 is 1, so it's not going to be 1. All right, so what we're going to learn how to do, if you do have a calculator, what I would like you to do right now is get it out. You know how to put in 4 to the 1/2 power in your calculator.
0.5.
You put it in as 0.5 precisely. Okay, what is it? 2? Do we get 2? So in your calculator, we're typing in 4 using your up arrow or whatever button your calculator has for your exponent. And you could just type in 0.5. Or if you wanted to put in fractions, because what if I wanted to take 4 to the 1/3 power?
0.33.
Well, it's 0.3333333333333. And we can't put that into the calculator, right? So do you see on your calculator if there are parentheses? Is there a left and a right parenthesis on your calculator?
Yes.
So if I were typing this into my calculator, I would do 4 with my exponent, and I would hit 1, and then the divide 3, but I would put that around parentheses to group that together. Because if I didn't, then my calculator is going to do 4 to the first, and then divide that answer by 3, because it's going to do order of operations. I don't put in the parentheses, which is going to get you a totally different answer. Okay, so in math, we have 4 basic operations. We have adding, subtracting, multiplying, and dividing. The inverse of addition is what? Subtraction. And the inverse of division is multiplication. So what's the inverse of something that has an exponent? 7 squared we know is what? Again, don't write this stuff down. This is just introduction. 7 squared is 49, right? So what's the inverse of a square? Rory? It is a square root. So what is the square root of 49? 7. So let's talk about a cube. 2 to the 3rd power is what? 8. So what would be the cube root of 8? It would be what? 2, right? Because what am I looking for? I'm thinking in my head, what number times itself 3 times is equal to 8? Well, 2 times 2 times 2, right? Okay. So what we're going to talk about today is we're going to talk about rational. What does it mean to be a rational number? Rational means it's any number that could be written as a fraction, right? So we're talking about exponents that now have a fraction in them instead of just an integer. Your whole quiz, all of your exponents were integers, right? Either a -2 or a +4 or a -3 or a +5. Now what happens if we get fractions in our exponents? All right, so really quickly, let's make this chart. I just want to make sure you are familiar with all of our different roots and get our vocabulary down. So we're going to talk about the inverses of each other. So we've got new operations. You're familiar with your basic for adding, subtracting, multiplying, and dividing. So now we're going to add in squaring as a new operation. We're going to add in cubing as a new operation. And there really is no term for, there's not like a fourthing or a fifthing. Don't say that because it's not proper. So we just say raising to the 4th power raising to the 5th power, and so forth. Raising to the 6th power, raising to the 7th power, raising to the 8th. However high we want it to go. We won't write them all down. So when we have those operations occurring, to undo them, just like when I have something like x plus 2, and I wanted to get rid of the plus 2, I would do the inverse, which is minus 2. To undo a squaring operation, the inverse operation would be to take the square root. The inverse operation of cubing something would be to take the cube root. The inverse of raising something to the 4th power is the 4th root. And the inverse of raising something to the 5th power would take the 5th root. And so on. Inverse of taking something to the 6th power would be taking it to the 6th root. 7th power, 7th root, 8th root, 9th root, 10th root, 12th, however many we want it to go to. Okay. So let's show some examples over on the right. Is everybody okay? Do I need to pause longer? Yeah. Okay. So for squaring, let's do things we're familiar with. If I had 3 squared, that's equal to 9. The square root of 9 is 3. So they're inverses of each other. So I'm looking for a number. I'm thinking in my head, what number times itself twice is 9? 3. All right, let's do a cubed. 3 to the 3rd. 27. So the cube root, does anybody know how to write a cube root? Yeah, so you do the square root sign, but we're going to put a little 3 in this space here, and we're going to talk about what that's called here shortly. So the cube root of 27 would be equal to 3. All right, let's do the 4th root. So 3 to the 4th is 81. The 4th root of 81 would be 3, because 3 times 3 times 3 times 3 is 81. And now let's do a 5th root. 3 to the 5th. So 81 times 3, 243. So the 5th root of 243 is equal to 3. So you've seen square roots before. Have you guys seen cube roots before? Have they talked about that in math class last year? A little bit? Okay, so these may be new. You've seen square roots, but maybe you haven't seen a cube root, a 4th root, or a 5th root. But this idea is still the same. All right, so now let's talk about some good vocabulary here. So let's write this radical sign down. So the square root, the cube root, the 4th root, the 5th root are all just what we call radicals. So radicals is just the generic name that we use for anything that has the root symbol. So this is a radical sign. Okay? It's not always a square root sign because you might not always be talking about a square root. You might be talking about a cube root or a 4th root. The little number that goes in here, the little check mark, we call the index. The index. So whatever root we're talking about, we call that the index. Whatever is underneath the radical sign, You're going to like this name. It's called the radicand. The radicand. So your radicand is under the radical. So if you hear me say radicand, you should know what I'm talking about. If you hear me say index, you should know what I'm talking about. So if I ask what is the index, you should say 4 or 5. If there is no number written there, we assume the index is what? 2, right? Because it's a square root if there's no number there. So if there is no number there, we assume the index is 2. All right. So we got our radicals. We got all that figured out. So can you simplify some radicals? First one up. Square root of 36 is 6. Good. Hopefully we're all masters of our squares. What are the perfect squares? Let's quickly make a list of that. The first perfect square is what? 4 followed by 9 followed by 16 followed by 25. Keep going. How high can we go? Yeah. Good. Good. Can you go further?
121. 144.
Good.
136.
Yep.
139.
Wait,
169 and 196. Those are always easy to remember because they're flips of each other. Nope. So now we're at 15 squared. 225. Yeah, it is 256. No, I'm just seeing what you guys got.
Yeah. Alright,
That's all I have memorized up to. I probably can figure it out. 256. All right, so at least make this list on your notes so you can reference it quickly. So these are your perfect squares. 256, 16, 17 squared has to end with a 9, right? 289?
I don't know.
Because I knew there was something up there. And it has to be a 9 at the end, right? 7 times 7 is 49. 7 plus 4 is 7 is 7, 8, 9, 11. And then you got the other 7 there, which would make it an 8. And then 2. I'm doing my math, my multiplication by hand in my head. Like I'm bringing down the space saver. Get my 2 rows. Okay, so we got our perfect squares. So you should be able to take the square root of any of those and get to the right answer, right? All right, what about our cubes? Cube root of 64. Well, let's quickly make our list before we even do this. Let's make a list of our perfect cubes. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. So our answer up here is going to be 4. Good. What's next? 5 times 5 times 5 is 125. 6 times 6 times 6. So 36 times 6 is what? 196? 36, 6, 6, 18, 19, 20, 21. No, 216, right? All right, we won't go any higher than that. So we got our cubes. How about our fourths? What's the fourth root of 1?
1.
Good. Fourth root of 1 is 1. Let's quickly make a list of our fourths. 2 times 2 times 2 times 2 is 16. 3 times 3 times 3 times 3 is 81. The quick trick for fourths is you're just doubling. So our first perfect square is 4. 4 times 4, not doubling, squaring it, would be 16. And then 9 and 9 makes 81. And the next would be 16 times 16, which is, what did we say that was, 256? We won't go any higher than that. Okay. All right. So we got the idea of different types of roots. Okay. So now let's bring in our fractions. So now, if you have a base to a fractional exponent, where 1 is in the numerator and some number n is in the denominator, whatever your denominator is in this fraction becomes the index of the radical sign. Well, the 1 technically, good question, it's going to then become the exponent on the outside. We'll get there. So it's just taking this whole thing then to the first power. Okay? So whatever is in your denominator goes here. Well, I guess let's just jump to that right away to save time. If that is something other than 1, so let's make it an m over n. So if I have my base to a fraction of something other than 1, this denominator still becomes the index of your radical, but then whatever your numerator is becomes your exponent on the outside.
Yeah, you sort of like.
It's okay, just write it down. We'll practice it. Alexa?
So you multiply the n and the n together?
Well, no, you'll see where we're going with this here in a second. Okay? So all we're doing is just going back and forth between fractional exponents and so forth. So if I had 125 to the 1/3 power, that really is the same as taking which root? The third root, or not the third root, the third index of 125. Look at your list of perfect cubes.
Keep always take the denominator as 5.
The cube root of 125 is 5. Because 5 times 5 times 5 is 125.
If it was like 2/3, would it be 6?
So if it was 2/3, let's go ahead and jump there. Thanks, Zax, for asking that question. If it was 2/3, then I would take the cube root of 125, and then whatever that answer would be, I would square it. So we said the cube root of 5, or sorry, the cube root of 125 is 5, and then if I square that, I end up with a final answer of 25. So it's equal to 25 would be my final answer. So what would be, for fun, if we made it 4/3?
Um,
5 to the 4th would be what?
600?
625, right? Okay. All right. What about 64 to the 1/6 power? Well, would that look as a radical? It would be the index. So it would be a 6th root of the index. The radicand would be 64. So what number times itself 6 times is 64? Yeah. Good guesses. It's always going to be 2 or 3. If I would have made this 5/6 as an exponent, then it would be what? So 64 to the 5/6 would be equal to the 6th root of 64 to the 5th power. Bless you. So it would be 2 to the 5th power. What did we say that was going to be? 32?
Wait, you know how 2 is squared and like 3 is cube?
Yes.
Would 5 be like pentagon?
No, we just say to the 5th power. There is no name for that. Good question. All right, we think got a handle on that? All right, so we just did all of this. So 216 to the 2/3. What will that get us? What's going to be my index? 3. My radicand is going to be 216. I'm going to take that whole thing to the 2nd power. So what times itself 3 times? Do we list this on our cube list?
Yeah, I think.
What was it?
4.
6 times 6 is 36. 36 times 6, wasn't that it?
Yeah.
So it was 6. So that becomes 6 squared, which would be 36. Good. Okay. Do we have the back and forth between this to this? Would you be able to go from this to this? So if I gave you one of these, would you be able to write it as a fractional exponent?
Yeah.
Okay.
I have a question though.
What? Go ahead.
Go back.
So we'll go back to that screen.
Yeah.
Okay.
Yeah. So how do you know what the 216th to the third?
Well, so you just need to think about what number times itself 3 times gets you to 216. Yeah, so you could do like 3 times 3 times 3 and see if that gets you there. Okay, so now let's throw in some variables into our lives. So we've got x to the 1/4 times x to the 1/4 times x to the 1/4. We're almost done. Times x to the 1/4. Do you have the same base?
Yes.
For everything?
Yes.
What do I do when I have the same base and I have exponents? Add them. What is 1/4 plus 1/4 plus 1/4 plus 1/4? So it'd be just x to the 1, which is just x.
Wouldn't it be 116?
No, you don't.
You don't.
No, you're adding.
Adding. 1/4 plus 1/4 plus 1/4 plus 1/4 would be 4/4, which is 1.
So you don't. I don't like it.
So it's just
It
x.
would be 4x to the first.
No, because remember you just add, if this was x to the 4th times x to the 4th times x to the 4th times x to the 4th, you would do 4 plus 4 is 8, plus 4 is 12, plus 4 is 16, so it'd be x to the 16th. But now it's just fractions instead. All right, let's try this one out. Jot this one down. Not that bad.
Yeah, it just looks like so much in one thing.
Okay, I think we can do it.
When like I do something like that.
Guys, this is literally the one time.
Huh?
When would you use like a phrase that long?
I don't know. Okay, so let's go back to our properties. We've got 2 things inside a set of parentheses being taken to a power, so what am I going to do? Distribute that 1/2. So 1/2 times 3 is what? Or I'm going to write it as 3/2. 1/2 times 4 is 2. 1/2 times 9, and I'm going to write it as 9/2.
You have to write it.
Yeah, keep it as a fraction. 1/2 times 2 would be 1. Now what am I going to do with my exponents on the x? Add them. 3/2 plus 9/2 makes 12/2, which is 6. Good. So x to the 6th. Y to the 3rd. Good.
That's the answer?
Nope, we got one more to do.
I have to get x to the 6th. Oh.
3/2 plus 9/2 is 12/2. 12/2 is 6. All right.
Is that the answer?
Let's do the hard one to end up. Here we go. Write it down. You guys want to be done, so we'll finish with the hard one. This is the hard one. It shouldn't be hard. So we got a 4th root of x to the 4th, y to the 3rd, z to the 6th. And we got a 4th root of x squared, y to the 9th, z to the 10th.
Yeah.
How can I rewrite the first radical as an exponent with a fraction? Alexa.
Well, you have the.
Wait.
So if I rewrite the radicand, what would be my exponent? It would be 1/4. Good. Remember, if my index is 4, it goes to the denominator. It's to the first power, technically, so my numerator is going to be 1. So now let's simplify this. 4 times 1/4 is 1. 3 times 1/4 is, I'm going to leave it as 3/4. 4 times, or 1/4 times 6 is 6/4. 6/4 reduces to 1.5, which is 3/2. Okay. If you want to put 1.5 for your own thought process, go for it. Just put it as a fraction. All right, what's this parenthesis going to look like? It's going to be a radicand of x squared, y to the 9th, z to the 10th. What's going to be the exponent? 1/4. All right, so 1/4 times 2 gets us 1/2. 9 times 1/4 is 9/4. 10 times 1/4 is,
10/4.
which reduces to 5/2. All right, let's go ahead and add.
Wait, make sure to reduce the y.
1 plus 1/2 is 1.5. We're going to write it as, I'm going to put my answer up here, 3/2. Now add your y's. 3/4 and 9/4 makes 12/4, which is 3. 3/2 plus 5/2 makes 8/2, which is 4. Good. That's your answer.